cities in flatland connected with m unidirectional roads. Directed graph. The cities are numbered from 1 to n. The flat FCF wants to set up the new capital city for this kingdom. For this kingdom, for all the cities there should be a capital. The capital must be reachable from all the other cities of the flatland. FCF needs the list of all the candidate cities. Okay, so all those cities which can be reachable from all the other cities. So what are all this? You are a safe programmer at this responsible for providing the list of FCF as soon as possible. So we are given n and m. Okay, each of the m line contains two integers denoting the road between A and B, and this is a unidirectional road. We need to find all those cities which are reachable from any other city. All those cities which are reachable from any other cities. Okay, and we need to find all those cities. What if it is not possible? Okay, the output file contains an integer denoting the number of candidate cities followed by the list of candidate cities in increasing order. What if it is 0? Okay, then I think we don't need to print it. Otherwise, let's see this example. We have 1 to 2, 3 to 2, 4 to 3, and 2 to 1. So which all cities are reachable from any other city? Is 4 reachable from? No, 4 is not reachable from 3 only. So 4 cannot be that city. 3 also cannot be that city. 2 is 2 reachable from any? 2 reachable from 1, 3, 4. Yep, 1 is also. Is it strongly connected? So if all, so that's why he's asking all the possible candidates, because there can be a lot of them if they are part of the same strongly connected component. Now if I know the strongly connected component, all the strongly connected components of this graph, let's say this one, this one, this one, this one, this one, and compress this graph to get all the strongly connected component and create the new graph out of it. So this graph will not have cycle, that means it will be a DAG. So maybe this one, maybe if we have this, what will be the answer for this graph? It will be 0, because this node cannot be reachable from this node, right? But it can be reachable, so that means only one sync node should be there, then only answer is possible. If only one sync node is there, can it be reachable from any other node? So come from this node, yeah, I can reach this. From this I can reach this. So yeah, from this I can reach this. So it will also, but if it has two sync nodes, T1, T2, then obviously it cannot reach, so answer will be 0 in that case. But if it is reachable, but if there is only one sync node, then answer will be all the nodes which are belonging to this strongly connected component. and this is strongly connected component. I think yeah, it's simple. We can run Tarjans or Kusarajo to find all the strongly connected component SCCs and create a graph, create the meta graph, create the new graph of the strongly connected components and get the out degree. So sync node will be the one which has out degree of 0. So find the out degree of all the nodes, right? Get the out degree of all the nodes. If there are at least two nodes with the out degree equal to 0, then answer is 0, because from this only it cannot reach to any other of the sync nodes, right? Yeah, but if there is only one node with the out degree of 0, that node will be the answer, not that node. All the nodes inside that node will be my answer. Okay, I think it's clear. We can implement it. First get the strongly connected component. Okay, second is create the new graph, and yeah, let's implement it. But which one, Tarjan or let's do the Tarjan one. Yeah, फिर कोसरा जो we are given n and m, a to b, and m, and m edges, m paths. Okay, semicolons doesn't matter. Now for each of them we need to how many edges are there? So the adjacency. The adjacency. Okay, so x to y there is an edge. So we do the Tarjan or Kusaraj? Kusaraj will be easier. Need to run to DFS Tarjan's one. How to find? Let's do Kusaraj only. What do I need to find? For each node to which, so every node belongs to which strongly connected component. That means I would need a vector of ID. That means what is the, or say which strongly connected component, what is the SCC ID of this node. Let's say everyone's ID is 0 initially. In my DFS call only we can have that. Okay, so we will need the which. Okay, let's write the Kusaraj only. For every node, if it is not visited, that means run a DFS from that node with the SCC ID. Strongly connected component is 1. Every time, so it will go for 1. Go and visit everything. Okay, we would need ordering also, right? Ordering, pass the ordering also. I think SCC would be required in second ones, because then only we will know. Let's create the reverse graph also, or adjacency of next. Reverse adjacency of y, dot place back x. So we have the reverse graph. First run the DFS and get the topological ordering on this graph. So we have, let's remove this initially. We have we need the ordering. Okay, so for every node, if it is not visited, run a DFS. Let's call it DFS1. We would need the visited vector also. Vector of boolean visited. Everything is not visited initially. Let's do the DFS1 on the node u, and what is the ordering of this node. DFS1, so mark it visited. Mark it visited and go to all the neighbors. Be over adjacency of u, go to all the neighbors. If neighbor is not visited, apply the DFS on neighbor with the ordering. And once I'm coming back from this node, we can push back the node itself. After this I have the ordering vector, but yeah, we need to reverse that to get the topological ordering. Okay, reverse the ordering, not begin. Okay, so in this order only, it is Kosaraju simple. We can go to all the node, this node over the ordering. So if it is not visited, I think, yeah, if this is not visited, we can apply the DFS2 on this node. I think we need to pass the SCC ID also. Yep. So and SCC ID to which it is first. Okay. And we need to mark visited. Let's mark every node as unvisited again. Visited of I is false, and we reverse the ordering to get the topological ordering. Mark the SCC, and then in this order only run the DFS. And once the DFS is complete, on this, that means it will find first strongly connected component, all the nodes in the first SCC. We can increment it here only, SCC ID ++, so that the next time I find 2, let's say 1 was strongly connected, 1 was, this 1 and 2 are in the same, so 1 and 2 will be visited. They will be given ID as 1, then 2, then 3. For 3 it will come and find it as not visited, so for 3 it will give the ID as 2. Okay, let's write the DFS2. It should be similar to this only, double passing. I guess the odd integer, passing the integer ID, SCC ID. So we mark it as visited. We mark this node as visited, and to which strongly connected component it belongs to. Okay, it belongs to SCC ID. Go to the unvisited node and pass the same SCC ID. We don't need the ordering. After this we will have for every node to which SCC it belongs to. Okay, now what we need to do, so once we have the, for every node we need to create, I guess, yeah, so for every node I know to which SCC belongs to. This belongs to 1, this belongs to 2, this belongs to 3. I need to create this graph 1, 2 and 3. Do we need to create the graph or just we can count it? The out degree of every, I think we can just count it, right? So if out degree we need 0, yeah, so we can go traverse over every edge and find the two nodes which belong to this edge, and find the id of these two edges. If they belong to different groups, then only we create this edge, this new edge. Yeah, if they belong to different group, then only we create this new edge. And we also need this one, we need the order also. So in this edge, okay, I need order also. So if 1 2 is different than 2 1, that means 1 2 is there. If 1 2 edge is there, then SCC of 1 and SCC of 2 will have an edge from SCC 1 to SCC 2. We don't need to create this graph, right? Because we can just increment the out degree of this SCC, out degree of this SCC, out degree of this SCC. So if in the, yeah, I think I got this. So yeah, we have marked. So okay, let's see nm, go read the edges x and y. It will work on the reverse adjacency. Yeah, it would have been a mistake. Visited SCC, go on the reverse adjacency, create the adjacency, reverse adjacency, create the ordering y 2 times. Okay, prevent ordering and go to each node. If it is not visited, then apply the DFS1 on that node and ordering. It will finally give me the order. So mark it visited, go to all the unvisited neighbors and pause the ordering. Once it is done, okay, so after this we will have the ordering vector. So finally we can reverse it. So we get the ordering, we can reverse it, then mark everything as unvisited, the ordering unvisited, and then to which ID every node belongs to which strongly connected component every node belongs to. After reversing this, we mark it as unvisited, go in this order and apply the DFS2 I and SCC ID keep on incrementing. I think it will be DFS2, it will be DFS1. Yeah, so assign the ID and go to unvisited on the reverse adjacency. It is on the adjacency. Okay, fine. Yeah, now go to all the edges, and from this edge we will have the nodes. How to read? Can we go to all the edges in this fashion? For int I is equal to 1, I less than equal to n, that means for every node, if I go to j over the adjacency of I, that means I to j there is an edge from I to j, and if they belong to different components, right? So if SCC of I is not equal to SCC of j, that means there should be an edge. That means out degree of SCC of j should increment by 1. Nope. Yep. Yeah. So we need the out degree vector. CC out degree of every node is 0 initially. So out degree of every out degree. So if from I to j there is an edge, that means, and they belong to different strongly connected components, that means out degree of SCC of j, the new graph, will increment by 1. But do we need an exact count, or we don't need exact count? Yep. Yeah. So finally we need to count how many nodes are there who have out degree of 0. No? So if it is greater than one node having out degree of 0, that means answer will be 0. Right. So because if this node is not there, so if, yeah, I think we can go this way. I less than equal to ni plus plus if the out degree of the SCC of I do we need to traverse on this? I just need to find how many in the new graph, right? In the new graph. So why to iterate over this? Just iterate over the SCC ID. How many? Yeah. Out degree of I. If it is 0, that means count plus plus. If count is greater than 1, that means answer is 0. Otherwise we can say out 0 and return. Okay, but if the out isn't it, so out degree of I, which out degree depends on the SCC. Out degree is only for the for this graph, new graph, not the old graph. So we'll have lesser number of nodes. Maybe it can be initialized as SCC ID size, not the next size. But does it matter? No. Yeah, we can, but let's see. So for I equal to 1 to n, go to every edge, and if they belong to different SCCs, increment the out degree of SCC of j. Yeah. So if this edge belongs to, if they belong to different group, so if here they belong to same group, so we don't add any edge. But if this one is there, in the new graph we'll have an edge from 3 to this component, right? Yep, I think this will do the work. And after that we can go to every, so what if there is only one SCC, and then it will assign everything as SCC1, but it will finally make it as 2. So why to do this one? Yeah, it will be only 1 less than SCC ID. And if it is 0, now I need to find how many sync nodes are there. So if the number of sync nodes is greater than 1, that means it is not possible. But if it is equal to 1, that means if it is equal to 1, that means all the nodes can be visited to the, and then I need to find which SCC ID is that, right? Which SCC ID is that? So maybe we can have here, so int SCC ID with that means let's mark it as 1. Okay, so if it is only one time executed, that means it will be this value. If I come here, that means SCC ID 1 is that SCC which has that SCC which is the sync node. Yeah, so I need to find all those nodes which belong to this SCC ID 1. Let's say, okay, so we can go to all the nodes now. And if their SCC of this node is equal to SCC ID 1, This node is in my answer. Is my answer is in my answer. Let's have this is very okay. You can push inside the answer. This means this node belongs to that. So what do I need to print? You need to print the number of denoting the number of candidate cities followed by the list of those cities in increasing order. Okay, you can just see out the answer dot size and then sort this answer. Sort this answer and then go to each node over the answer and just see out the x. Yep, should it work? Yeah, I think it's verify if there is no compilation error. Count was not declared. Did you mean int? Count was not declared. Let's declare it. It should be initialized with 0. Yeah, no compilation error. Let's verify. So we have nm read the graph, create the graph, get the ordering, reverse the ordering, mark everything as unvisited, go in that order and do the DFS. It will assign every node their ID to the SCC they belong to, right? Yeah, so if there is only one SCC, it is 1. It will assign 1 to everything and it will increment it to 2. That's why we will do. Okay, this works. Now find the out degree. So SCC I is not equal to SCC j. That means out degree of this node increases by 1. Yep. Now go to all these SCC IDs because it will increment. Yeah, it works. If the out degree is 0, that means take that and count plus plus. That means this is sync node has out degree 0. And what is that sync node? So that will be I only. So if the count is greater than 1, that if there are more than one sync nodes, that means one of them or both of them cannot be visited from any of the other. Yeah, both of them cannot be the candidates for a capital city. That means yep, it is 0. You can return 0. Otherwise we have otherwise we need to find all those cities which belong to which have the ID, which have their SCC as this. Okay, so if this we have the answer, number of cities is this one. Go sort it and print that city. Yep, let's try to submit this. Capital city. Okay, 4, 6, 8. Have I missed anything? It will work. I think it should work. My code is very. I think I can write beautiful code. Okay, working. Don't give TLE after 20. Oh, on 20th it gives the wrong answer. Why? What's wrong with this? At least one node. Why would it give the wrong answer? Yeah, duplicate edges I haven't handled. Adding edges only when there isn't an edge between the vertex U and V did the trick. But does it matter? Adding edges only when there isn't an edge between the vertex U and V. Major theta. This theta flow. The answer should be considered. Adding the edges only when there isn't an edge between vertex U and V did this trick. I think only that, but why would it? Okay, so adjacency x to y, let's have it as set. Then I'll have only one edge. Afraid it will throw it clearly now, or it won't. It will be insert. X to y will be one edge only. Y to x will be on one edge only. My ordering, okay, parallel edges will be handled. Reverse the ordering, SCC. See, no compilation error. It's quite slow, yeah. Now if it throws TLE, I won't solve it. Yeah, we can solve it using the IDs. Yeah, by assigning each edge an ID and then write the DFS in such a way that we don't process an edge with the same ID twice. Where did it fail? Wrong answer. Why it is wrong answer? What could be the case? So when I'm traversing over here, it will also increment the out degree, right? Hmm. Why it is not working? Yeah, I suppose has this kind of thing. Like weird. At least 20 was passed. Did it pass? So there should be given that at least one city is reachable from all the other cities, or they need to change the test case, including the test case where the answer is 0. Cities in increasing order. I'm printing them right. Yeah. There might be duplicate edges. Adding the edges only when there is an edge between U and V did the trick. The test data is wrong. There might be multiple SCCs. The answer would be considered as each SCC as a node from a tree and output of the root. I just found this. Output it increasing order and got an AC that isn't right. Okay, why my I to face this problem is in one go. The vertices ordered are present in SCCs whose size is greater than 1. Consider your DFS wrong answer iteration count over degree. Iteration to count the out degree. DFS accepted. Use this. Am I doing something wrong here? Because every node will have SCC starting from 1. Yeah, so if suppose everything belongs to their own SCCs, then will it how much it will be? 1, 2, 3, 4, 5, 6. I guess this should be equal to which it is. So suppose 1, then 2, then 3. It will go visit this one. It will go mark 2 and 3. It will become 4. Yeah, it should be 3 only. So 1, 2, 3 will be visited everything. Whatever there should be a minor mistake. I'm going to stop here. Sort and then write all the answers. What is wrong in this? So if there are parallel edges, I have removed every parallel edge. Will they affect my new graph? This out degree value? No, right? Because I am just worried about out degree equal to 0. I just care about the nodes which have out degree 0, not their actual count. Maybe it is done by one node, 1 edge, 2 edge, doesn't matter. Whatever. I think 20th was passed. That's okay.